All right, so Unit 6, Lesson 7 happens to be one of my favorites. It's called percent error, and it's like percent of change, but basically what we're saying is sometimes we do things and we're wrong, and we want to know like how bad we are, as in like how off we are. And you can't just be like, oh, I was off by 2 centimeters. Well, 2 centimeters might be a huge deal, and it might be no big deal at all. So if you look at it as a percent, then you can really have an idea of how close you were. So first thing we need to look at is that in order to find percent error, we need to do the difference between the actual and the estimate. The estimate is also sometimes called the observed value. Sometimes that's easier to think of it that way. So the top number is going to be a difference where you're going to subtract the two numbers. The bottom is your actual value. And then on the right, the same x over 100%. So nothing new there. And this is a proportion. The difference between actual and estimate is called absolute deviation. You're always going to use a positive number for this. You're never going to have a negative. So we're just saying like, what's the difference? How far off are the two numbers? And then the estimate or the observed value is the number that you are finding the difference with. So, example, Jamal needs to purchase a countertop for his kitchen. Jamal measured the countertop as 5 feet. So he estimated, he observed that the piece he cut was 5 feet. And it says the actual measurement is 4.5 feet. Bummer. So we have an observed, what he thought it was, and we have an actual. What is Jamal's percent of error? So first, we need to find their difference. Like, what's the difference between the two numbers, the actual and the observed? So the difference is 0.5, right? He was half a foot off. And the bottom number has to be the actual. The actual measurement is 4.5. So he was off by 0.5. That goes on the top. That's your difference. And the 4.5 is the actual that goes on the bottom. And you cross multiply and divide just like we do with any proportion. And we would get 11.1%. So his actual countertop was 11.1% too low or too small or too short. That's a pretty huge error. If you're like, oh, he was off by 6 inches or, oh, he was off by half a foot, that doesn't really tell us anything. This percent is telling us he was more than 10% off. That's pretty significant. All right, find the percent error for each student. Samantha S. Sloppiness measured the volume of her soda before she drank it for her mid-morning snack. She measured the volume of the 12-ounce bottle to be 14 ounces. So the actual is actually a 12-ounce bottle. So up here, we will put actual in orange, just so we remember. And then she measured it to be 14 ounces. So she thought, right? She observed that it was 14 ounces. So the observed value is going to be the one that we'll do in yellow. Now notice I didn't highlight the whole top because the top is when you subtract the two. So I need an observed value and I need an actual value. The bottle is actually 12 ounces. She observed, she thought, she estimated that it was 14 ounces. So top number in the proportion, how much was she off by? The difference between 14 and 12 is 2. So we're going to put 2 over the actual 12 ounces, and we're going to find what percent that is out of 100%. So 12 times x equals 2 times 100, and we divide both sides by 12, and we get 16.6 repeating percent equals x. So she estimated, or we could say she measured 16.6 repeating percent too high. She came in at 14, but it was actually 12. All right. Clyde Clumsy was directed to weigh a 500-gram mass on the balance. So when you buy these in science, a 500-gram mass, somebody else has already made sure that that's exactly how much it is, and it is labeled 500 grams. After diligently goofing off for 10 minutes, he quickly weighed the object and reported that it weighed 458 grams. So he weighed it, he reported that he estimated, he thought it was 458. So the actual weight, or the actual mass, I should say, 500 grams. He reported 458 grams. So how much was he off by? So if we do 500, take away 458, we're going to find he was off by 42 grams. Well, is that a lot or is that not a lot? So we would put that difference of 42 grams over the actual 500 grams and say, well, what percent is that out of 100%? We would cross multiply 500 times x equals 42 times 100 and divide both sides by 500 and get 8.4%. X equals 8.4%. So he only got it at 458. It should have been 500. So let's see what we would say. He reported that it weighed. So his report was 8.4% too low. Yeah, that's pretty significant. I mean, it's a 500 gram mass. We would expect you to get something pretty darn close, like 498 or 499 or maybe 501. All right. Pretty Patty Pestilence had casually recorded her grades for the 9-week grading period in her notebook. She concluded she had 250 points out of 300. However, Miraculous Mac, her chemistry teacher, logged that she had earned 225 points out of 300 and recorded her grade as a C for the grading period. So she concluded, she observed, she estimated that she had 250 points out of 300, and she had actually earned 225 points out of 300. Now, I will tell you that out of 300 bit, that is going to throw you off. You notice they're both out of 300. So the part that you're finding the difference between is she observed that she had a 250. She actually had a 225. Those are the numbers we're finding the difference between. The 300 actually does not come into play for us. So she was off by 25 points, and the actual score that she got was 225, x over 100%. So we would cross multiply 225 times x equals 25 times 100, so 2,500. Divide both sides by 225, and we're going to get x equals 11.1 repeating percent. That's a lot. I mean, think about your grade. Think about if you thought you were getting a 90 and all of a sudden you found out you're getting a 79. So she concluded her score. She concluded her score was 11.1 repeating percent higher than it actually was. So a little bit of this comes down to like English class and the idea of like answering a question and having to sort of look at the wording. You can't just be like, she was 11.1% high. Well, what does that mean? She thought she got a score 11.1% higher than it actually was. Drew D. Dingaling came to Miraculous Mac with a problem. Drew was told to measure 50 centimeters of copper wire to use in an experiment. Since his ruler only measured 45 centimeters, he used this amount of wire, and the experiment was a failure. So he was told to measure 50. So the actual measurement needed was 50 centimeters of copper wire. What he did, his ruler, his measurement, he came up with, measured to be 45. That was his measurement. So the actual, right, what the project actually called for was 50 centimeters, and he only estimated 45 centimeters of wire. So we would say, what's the difference? 50 minus 45, so it's a difference of 5. So we would say 5 centimeters off out of the actual 50 centimeters. Now this one you might be able to sort of figure out in your head. If you wanted to get from 50 to 100, you could double, or you could still do 50 times x equals 5 times 100. Divide both sides by 50 and find that x is 10%. So his measurement was 10% too low, and that's a lot. That's a significant problem. All right, Henry Heavyfoot was just fined for speeding by Officer O'Rourke for being clocked actually traveling at 65 miles an hour in a 55-mile-an-hour zone. Henry reported that he observed his speedometer reading only 55. So he was actually going 65. So our actual value, 65 miles an hour. And he thought, right, he observed his speedometer only going 55. So actual 65 miles an hour. In case you're curious, if you change the size of your tires, your speedometer can actually be off. So that's probably the only thing he could potentially argue. So if we do 65, take away 55, notice I'm always getting a positive number there because I just want the difference between the two numbers, not which one is higher or which one is lower, because we're going to write about that in our answer. So the difference was 10. miles per hour over the actual 65 miles per hour. And we want to know what percent that is. So 65 times x equals 10 times 100, and divide both sides by 65. You're going to get x equals, or approximately, this one's a little messy, 15.38%. So he thought he was going 15.38%. Now I can either say about, or I can put in the approximate symbol. About's going to make more sense because it's a word problem and we're putting words in our answer. He thought he was going about 15.38% lower than he actually was. Last but not least, Wilhelmina Whitty was assigned to determine the density of a sample of nickel, the metal, not the coin. When she finished, she reported the density of nickel as 5.59 grams per milliliter. So that's her report. However, Miraculous Mac knew the density of nickel was really 6.44 grams per milliliter and showed her the data in the chemistry textbook she could have read for homework. So when we're looking for things like actual values, we use things like textbooks. So 6.44 grams per milliliter. Now, here's the thing. Sometimes people get hung up on, I don't know what a gram per milliliter is. Doesn't matter, because you're going to have grams per milliliter over grams per milliliter, and you're getting a percent. The units are completely irrelevant as long as they are the same. So the difference between the two would be the 6.44 take away the 5.59. We're going to get a difference of 0.85. So 0.85 grams per milliliter over the actual 6.44 grams per milliliter. I forgot to write down, she thought it was 5.59 grams per milliliter, but that's what I used in my subtraction problem over here to find the difference, equals x over 100%. So I'm going to cross multiply 6.44 times x equals 0.85 times 100, which is going to move my decimal point 2 places to the right, leaving me with 85. So I can divide both sides by 6.44, and I would get x is approximately 13.2%. So she observed 13.2, or about, I'll put the approximate just because I don't have space over here. She observed about 13.2% too low. All right, so solving the proportion, not terribly difficult. Setting up the proportion, really going to be based on you reading the question and figuring out the difference between what is the actual value and what is the observed value, or the estimated value, however you want to put it. And then you solve it and you write an answer in words.